is an RMU and why is it important and why is it used in all the projects? Basically, an RMU, the term RMU stands for ring main unit. The RMU is a vital part of the medium voltage power distribution. The RMU at every project is the tapping point that connects to the utility network, the medium voltage incomer, which is usually 11 kV, for example, in residential projects, and let's say the residential complex projects. So it is the point at which you tap from the available incoming medium voltage cables. So the RMU enables to connect all the loads in a ring fashion. Therefore, when you are connecting all the projects or all the, let's say, the transformers and the equipment in a ring fashion, starting from the primary substation, you are providing power redundancy and therefore ensuring that the power is always available in case of failure in any part of the network. This is one advantage. In brief, we will go in detail in the next slides. Plus also it enables you to isolate the faulty equipment from the network without having any downtime and without affecting the other loads or the other transformers. So let us go on in detail. First of all, I just want to give a brief about this is like a very high level explanation about the RMU configurations. In what configuration are the RMUs available? So basically, in a very basic and straightforward way, you have two configurations, the TRM and the QRM. A TRM RMU is, as you see here in the schematic or a small sketch, single line diagram. It's basically a triangular ring main unit, ring main unit, which means that it has 3 terminals, 2 terminals for the incomers and 1 outgoing terminal for transformer connection. Therefore, it's used for connecting 1 transformer only to utility. So if I have a project where I have 1 transformer, I would use TRM. Actually, it's not my decision. The decision is usually, if my scope is not the HV, the decision is usually by the utility company to provide a suitable RMU for a certain project. So in this case, every RMU, regardless of the configuration, has 2 terminals in the incomer side, as you can see, because you want to connect your project to the ring. I have an incoming cable coming, let's say 11 kV, it's coming here. Then I have the outgoing cable continuing to the next load or to the next project or to the next RMU. So these two are standard for all RMUs. I have an incoming, 2 terminals from the incoming side, and then I have the outgoing side feeding the transformer, the distribution transformer. So here I have 3 terminals. It's a TRM, triangular RMU. Then the quadrilateral ring main unit is basically an RMU with 2 outgoings, therefore enabling to connect 2 transformers, 2 distribution transformers to the ring network. So it has 4 terminals, 2 terminals for incomer. As you can see, my cable is coming from here usually, then it will continue. So 2 terminals for incomer and 2 outgoing terminals for transformer connection. This is a mistake here actually. It's used for connecting 2 transformers to utility. Therefore, as you see here, an RMU is a sort of modular or contained switchgear having two incomers and two outgoings, or two incomers and one outgoing. The incomers can be disconnecting switches, manual disconnecting switches, or in many cases and most cases motorized breakers. This enables remote control of the RMU from the central utility office via what is called an RTU, remote terminal unit. So usually what would happen is that each project is having this as motorized breaker, which can be controlled from a central location in the utility company, therefore enabling opening, closing them in the case of any fault or any reason. For any whatever reason, they can have a remote control over them in order to provide the required functionality. The outgoing is connecting to the transformer, as you can see here, and it has all the necessary protective functions to protect the transformer. So imagine if you were protecting the transformer to the ring directly, you would not have the benefit of being able to disconnect it from the network, and you would not have the necessary protective relays in order to ensure no damage happens to the transformer in case of any fault or any short happening. Therefore, you can't isolate the transformer from the network without having an RMU. So these are the RMU configurations and a brief on what is the RMU and what does it consist of. So why do we need an RMU? As we just discussed briefly, the first and most important reason and the fundamental reason of why you need RMUs is for redundancy of utility feeders and to provide uninterruptible power supply. How is this? This happens since you are able to connect all the loads in a ring fashion. Therefore, you have for each load or each, let's say, transformer combination, you have two feeders coming. Therefore, the purpose of the ring is that in the case of failure of one of the cables or one of the feeders, you can transfer the load to you can feed the power through the other feeders. Plus also, as you will see in the coming slides, whenever any fault happens in any part of the network, you would be able to isolate that fault by changing the breaker configuration or by opening a certain part of the network and isolating that fault in order to ensure continuous power. Therefore, you are providing redundant power for all your projects or for all your loads. The second reason of why we need an RMU is for isolating faults and faulty equipment within the distribution network. So let's imagine that we have, I will explain it in detail in the coming slides also, but as a high level explanation, let's imagine that we have a fault that took place in one cable, for example, the cable connecting a certain project to another, since the 11 kV is running in a ring manner. Therefore, let's assume a fault happens in one section of the distribution network. That section can be isolated and the power can be transferred from the other feeder in order to ensure that continuity of the power supply. Plus also, if any fault happens at any of the equipment, for example a transformer, let's say, you would be able to isolate that transformer. You would simply disconnect it from the ring network without any downtime to the other loads in the same network. So I would be able to disconnect any faulty equipment. So it's like I have a tapping point to the 11 kV network or to the network, whatever voltage it is, through the RMU. The RMU is like my tapping point to the available ring from utility. So I will easily disconnect it and isolate it from the network. The third reason is that RMUs have protection relays for protecting the connected transformers and equipment. So as we have shown briefly earlier, the RMU outgoing is usually having all the protective relays and functionalities to isolate or to disconnect the downstream transformers in case of any fault or in case of any reason that might cause damage to the transformer. Therefore, I am providing additional layer of protection to my transformers from the incoming network, distribution network. So let's go briefly through these points regarding the ring distribution. Modern utility power distribution is done in a ring main fashion. Ring main network power distribution is achieved by feeding the network from two different feeders and forming a ring or loop. So you provide your ring by feeding two cables from two different either sections in the same substation, or from two different substations, let's say, providing more redundancy to your network. So in case of power outage in one of the feeders, network power is fed from the second feeder, as we have mentioned earlier. In case of a fault taking place in any section of the power distribution network, that section can be isolated and power supply can continue to the remaining parts of the network by utilizing power from both feeders at the same time. So how does this happen? Let's go into a certain scenario and provide a detailed explanation of how a certain case might take place and how the RMU would help us overcome that case in a certain scenario that we will assume. So as you can see here, this is a typical ring, power distribution ring network. So I have here the primary substation, 33 over 11 kV transformers, for example. These are the downstream, these are the main breakers at the primary substation, and this is a bus coupler connecting these two sections from these two separate transformers. So this section is fed by one transformer, this section is fed by another transformer, and my ring is going like that. This is the outgoing from the primary, from here and here. Then the ring is starting, from here to here is a cable. Let's say this is a project several kilometers away from the primary substation. This section is a cable, then going through the first RMU, another connected by cable, maybe this another project number 2 several kilometers away, going by 11 kV cable, RMU, cable, RMU. The same goes on till I reach the closing point of my ring network. So connected to each RMU, you can see here is a downstream distribution transformer. Then all these are LV loads, let's say. So this is a distribution. Let's say in this case, we are talking about a certain case, 33 over 11 kV. Then the ring is 11 kV, as is the case in several projects. Then the downstream here, let's say this is an 11 over 0.4 kV, and connecting this project, the same here, the same here. So in a scenario 1, let's call it normal operation scenario. What's happening here? Whatever is clouded with green has power and it is closed. The incomers are closed. Whatever is having green color is closed. So in this case, I'm feeding the power from this feeder. As you see, power goes on like that, goes on like that, reaches here, and then at a certain point in my network, I'm opening one terminal of the RMU. So this feeder stops here. It's connected from this. And the second part of the ring is connected from here. Since this bus coupler is open, no power is flowing here and no power is flowing here. So this one is providing power to the second half of the ring circuit. So you see it's reaching up to here and this terminal of the RMU is open. Therefore, my loads, my 11 kV network is up and running. Okay, so what would happen if a certain part of the network is faulty or goes down? So a certain scenario, let's call it scenario 2, a fault happens, for example, at the primary substation. So let's say a certain fault causes the feeder from this transformer to disconnect. So therefore, all this part of the network goes into red color. As you can see now, this section, due to any reason, due to any fault, is faulty and it trips, for example. So still my bus coupler was open. So the power, all of it is cut up to here, where I have assumed that my terminal, my RMU terminal is open. This section is up and running, but due to the fault here, the power have disconnected to all these loads. So how the RMU would help us to overcome this and to ensure continuity of the power supply? As we have mentioned, one of the main reasons why the RMU and the advantages of the RMU, why it's used in all projects, is to provide redundancy and to ensure that the power is available in case of faults happening at several locations of the network. So let's see how the RMU would help us to overcome this. What would happen in this case is that the bus coupler in the primary substation would close. The bus coupler was open earlier. So the bus coupler would close, and still my network, my ring network is open. It's not continuous. So this one still it's open. So I would close this bus coupler and the power would flow from here all the way to feed the loads which were disconnected earlier due to the fault happening here. So the RMU since has helped me to connect all my loads in a ring manner, and now I'm using the advantages of having my loads connected in a ring manner. Therefore, I have overcome this scenario by closing the bus coupler and feeding all these loads. So as we saw, a fault, the first case that we had was a fault at the primary substation. We assumed that this part was faulty, and immediately we have overcome this by using the bus coupler here to feed the other part. So let's go another scenario. So scenario 3, what we would assume is that a fault at any section in the distribution side. So what would happen? Let's assume a fault due to a damaged cable between RMU number 2 and 3. So here is a project or an RMU, and here is another RMU, let's say several kilometers away, and they are connected by cable. As we have mentioned earlier, the 11 kV is running connecting both of them. So let's assume that this cable goes faulty. Something happens here, whatever reason, and the cable is faulty and it does not deliver power to the remaining part of the ring. So as we said, in a normal operating scenario, this one's fed from here, this fed from here. So this section is up and running. It's not affected by this. Now I had a problem in this section in the distribution side this time. So this one, since now it's faulty, the power will not continue to reach here. These ones are red in color and they are disconnected. Let's see again how the RMU would help us to overcome this and to enable us to repair that fault without affecting the power distribution in the network. So one possible solution for this is that what I would do, since my network was earlier opened in a certain part of the ring, now I have to feed this section which the power was not reaching. Now it had stopped here. I have to bring power for it from the other side of the ring, from here. So the power was available from here. What I would do is that I would close this part of the RMU and power would flow from here all the way to reach the RMU here, which didn't have power due to this faulty cable. So I have now ensured that power can reach the remaining part of my ring from the other side or from the other feeder. But now I have a problem. My cable is faulty here. So what I would do is that this part, this terminal of the RMU would be open, whether remotely or locally. It would be open from here, and this terminal also will be open in order to isolate this faulty section. So this brings us to the other advantage of the RMU, which we have mentioned earlier, isolating faulty sections of the network for maintenance and to avoid servicing this part or replacing this part without any downtime to the remaining part of the distribution network. So now I have opened this one is closed, therefore power is coming here. This section is open, and this section is open from here. This part now is isolated, and we can work on it, whether to replace the cable or to test it or to trace the fault, do whatever we need in this section, and all my loads, all my projects, all my RMUs are having power and are not affected by this faulty section of the network. So as you have seen, the RMU is a very vital part of the power distribution network, and I hope that this brief and high-level explanation have cleared this RMU for you, since the RMU is usually like a black box for all engineers, and I feel that such a high-level and brief explanation with some practical examples would help to clear this in our minds and enable us to understand the RMU whenever we see it and whenever we discuss it in any one of our projects. Thank you very much for watching, and I hope that you have enjoyed the video and benefited from it. So I appreciate your support by subscribing to the channel, pushing the bell notification, liking the channel, and sharing it to all your colleagues and whoever might benefit from it. Thank you very much, and looking forward to meeting you in future videos.